Natural Future of Cosmetics team at Shannon ABC and MTU Kerry are delighted to welcome our guest speaker for today's manufacturing event. It's the 6th event in the NACO series. And today we are delighted to welcome Paolo Camattari from Linus Life to provide an overview of manufacturing considerations for cosmetic SMEs. So Paolo is the Research, Development and Innovation Manager at Linus Life currently, and after obtaining a bachelor degree in chemistry, Paolo's career in cosmetics started by working as a formulation chemist in a lab at an Italian ingredient distributor. Paolo continued his career in the hair bleaching department of another Italian contract manufacturer, adding expertise in hair products for professionals, and in specific, from a technical perspective, in making powder products from formulation design to the manufacturing scale. Paolo's cosmetics formulation was completed when he joined Oriflame in 2007 as a raw material investigation chemist in the colour team. Paolo's career progression continued by moving into the skincare team, and in November 2019, Paolo joined Cosmetic Creations in Cork, which are now known as Linus Life. The role is central in the interactions between departments and key in the whole journey of product development from concept to industrialization. So without further ado, I'll now hand you over to Paolo to begin the talk. Thanks, Paolo.
Thanks, Daniel, and thanks, Eve and the team in Channel ABC and MTU to give him this opportunity. It's, as you mentioned from my bio, cosmetic has been pretty much my bread and butter for the last 20 years. So I'll be happy to share my expertise as much as I know with the audience. So we're going to talk about manufacturing of cosmetic products. I don't know if you're familiar, but just to give like an overhead summary of any manufacturing environment, really. The factory is where the magic happens. The flow of the materials come in, and we're talking about ingredients, but we're also talking about componentry, bottles, pumps, labels, boxes, everything gets into the warehouse. Then it's dispatched from the warehouse to the floor. The manufacturer, which in the case of cosmetic is in 2 steps, manufacture of the bulk and then the filling of the bulk. There's a quality control involved pretty much in every step. It's not just an end step after the manufacture. Quality control is involved in incoming materials, bulk checks, check of like inline check of packaging and filled products. And then everything is kind of gathered together on a pallet, put on a truck, and eventually gets distributed to the retailers or the end consumer. Today we're going to talk about the cosmetic going from the product design to the final product that you can find on the shelf or in people's houses. This is the industrialization happens in one specific phase, but it really starts with development. So it's a continuous flow. So some of these, of what I'm going to say, whoever has attended other NACO events will probably be familiar with already, but it's just to make that sense of everything being interconnected. They're going to speak about incoming goods and industrialization, and then quality checks, filling, and packing. So scaling up, as I mentioned, starts during the development phase, and it starts with the selection of raw materials and the selection of the components. Obviously, if you are a brand owner who wants to launch his own product, you need to know what raw materials go in the finished product, how you want to sell it. So what is the final packaging, how the packaging is going to look like, and everything has an impact in terms of cost. So the formulation development is where this information starts to be fed to the customer. At this point, scaling up is when all the formulation work is done, the testing work is done, the product is registered, so it's ready to be available for the market. That's where procurement kind of takes the baton, and they start to check with the suppliers. The key informations that you need to know at this point is minimum order quantity and lead time for both raw materials and componentry. It all starts from how big the size of your order is going to be, because the size dictates how much raw materials you need to order and how much components you need to have in-house to fill the order. Depending on how much of these single elements, each one comes at a cost. Obviously, the bigger the volume, the cheaper the cost. So it's more convenient, but at the same time, it all depends on the order. And as I said, for raw materials, it might be quite relatively easy to find different kind of players in the supply chain that kind of tailor make the sample size to your needs. For componentry is more difficult. Componentry tends to be available in 5,000 lots or 10,000 lots. So a brand owner or someone who wants to launch a product in the market needs to bear in mind that it's something that you need to consider. You can't really launch a product in hundreds of units. You kind of have to stick to that quantity, and that drives the cost and also the other side effect of what to do with the unused componentry. How often are you planning to reorder this? Hopefully often enough. That means that your product is successful in the market. But these are all indications that you need to bear in mind. Procurement then has a direct link with planning in the manufacturing side, because obviously there's no point of planning or schedule a production if the lead time for the raw material is or the raw material is going to be delivered after the production schedule. So planning needs to know that information as well. Raw materials are ordered and the schedule depends on the longest lead time. In the meantime, raw materials start to come in. So the warehouse starts to have this key role in ensuring that everything is sorted properly, and whenever the day for manufacture is here, everything is lined up and ready to be dispatched from the warehouse to the different departments in the factory. The warehouse has this kind of critical role. It's a neuralgic point of any factory, because a warehouse is where raw materials are stored as they are delivered. Same way the components are stored when they're delivered. And as I said, if we're talking about thousands of units, so it will take space, at least at the very beginning, that the more you use, the smaller you can downsize. But at the beginning, you need to have enough space for everything, and you need to have enough space for everything separate, but also when things are put together. So when the bulk is made, you need to have space to return the raw material that are not used, because remember the minimum order quantity, but also the bulk between making and filling. It needs to be stored, can't be stored on the floor. It has to go back to the warehouse. And the same way, once the bulk is filled, the unused packaging goes back in the warehouse, and the finished products are back in the warehouse, waiting for the delivery truck to collect them and then ship them out. So for this reason, the warehouse is also crucial in terms of flow of materials and people. It's important to organize or to have like a proper idea of what needs to move in order for first of all, people to be safe, but also for the work to be efficient. So we're talking about the warehouse as the first port of call for incoming goods. Once the elements for your finished product are in, there's tests that need to happen. So some tests are on raw materials, of course. Every raw material comes with a certificate of analysis stating the specific batch that is referred to the material and that's going to be used in the production. And the certificate of analysis states the critical parameters. By this, I mean, for instance, the melting point for a wax. And these are, depending on the capability of the manufacturer, there's some checks that can be and then should be double checked just to make sure that nothing has happened to the raw material in the transport from the supplier to the warehouse. And also the certificate of analysis reports a shelf life or an expiry date or a retest date. So this information is needed in case the raw material is not used all in one go. A system like an MRP or like a quality system should highlight when the raw material needs to be either recontrolled or disposed of, and a fresher raw material needs to be ordered. When it comes to the organoleptic characteristics, the quality control requires a standard from formulation. I mean, these are the appearance, the color, the odor, just to make sure that there is consistency between the sample used in formulation and the sample that's going to be used in the bigger production. For packaging, the tests are nominal volume. So if a bottle is 100 ml, is it really a 100 ml bottle? The integrity, especially when it comes to glass, not just because of the fact that whatever is broken can't be used, but also because whatever is broken could be a safety hazard for the operator who needs to handle the box or the single units, just to avoid accidents on the floor. The packaging conditions are also checked. Is the packaging pre-assembled or loose? What I mean by this is, for instance, if you have, if your product goes into a bottle with a pump and a cap, is it pre-assembled, or will you have a bottle and then separate you have the pump and separate you have a cap? More often than not, it's easy to have the bottle on their own, but the pump and caps can come together or not. And that, I'm going to cover this later on in the presentation, but that has an implication further down on the line. Labels are checked as well. They're checked in terms of print, not so much for the content of what's on the label, but for the, is it readable, especially is it readable once the label is applied on the bottle? Because if you have like a clear label with black writing, it is readable. But if you find out that the packaging is a black bottle, it's not really something that there must be something wrong that needs to be flagged. And the adhesive type also something that needs to be double checked, because you need to make sure that your label sticks to the material of your final bottle, for obvious reason. But these are all checks that need to happen beforehand, because if they happen later on, once things are on the floor, it causes massive disruption to the flow, to the fulfilling the orders, and that's where you don't want anything going bad. So now we have all the materials. We're going from bench to full-scale vessel. So it means that we have done all our trials in beakers, and usually in formulation lab, you would operate maybe up to the 1 kilo batch size. in an open beaker. Then some lab have a capability of upscaling slightly, having this kind of hybrid semi-pilot vessel where you still have your glass container, but it's a closed system. So you can't really play around with the type of mixing, or you can't stick your spatula in the beaker to give the extra bit of mixing and helping to, say, scrape the walls. But at the same time, you see how long the mixing of the components need to happen, how have an understanding of how that reflects from your mixing time in the lab to scaling up. And then this one, obviously, it's not an industrial setup. You move up then to a more industrial setup where it's a proper, even closed, no see-through containers. Usually these kind of vessels, they have like a small opening, it's a small window and the light inside. But between splashes and the fact that you can't really move or go around it, it's very hard to understand what goes on in the vessel. So the ideal scenario is when your formulator and your operator speak at this level, because the formulator brings the expertise from a formulation point of view and how the ingredients interact with each other, and the operator brings the knowledge of what's going to happen in the factory. So at this point, the operator should know what goes on inside because he has seen it here. This phase is not available everywhere, but the expertise at both ends is. So it's just a matter of making sure that the communication happens. The quick question for upscaling are, what will I use in terms of vessel size, the size of each phase, what type of mixing do I have in the vessel, and is there a vacuum? And these are all fixed elements. The vessel gives you a lot less freedom to interchange any of these elements. Your vessel is efficient between 30% or 40% of its nominal volume to 90% of its nominal volume. So you need to know, depending on how big your vessel is, you need to know if you're able to, or how big the batch is going to be. If the batch falls outside that ideal window, you have to start to think of plan Bs in case something goes wrong. And together with it, the size of each phase, because if your total batch size is 800 kilos and you have 1 ton vessel, it's fine. But if your first phase is only 100 kilos, then it's not okay. And I'll show it later on in a little diagram what I mean by this. The other question is, how will I make it? So what's the most efficient way of ensuring that the product that I see from the lab is not only reproducible, but reproduced with the same quality, if not better quality, to an acceptable standard for the final user. So it's the number of phases and the order of addition of the phases. Is recirculation needed, and is it feasible with the design and setup in the factory? What's the time energy input compared to what I've seen in the lab? And what's the mixing speed, again, in reference to the lab environment? So in terms of vessel, you could come across anything from glorified pots to engineering masterpieces. So this is the first example. I think it's pretty obvious. And this is, for want of better words, it's not very different from what my grandma used to do to cook pasta in camps. But basically, the thing is, it's a vessel, it's a stainless steel vessel where mixing needs to happen. The flexibility of these type of vessel is so you still have limitations with this. It's the limitation in terms of what type of products you can make, because anything more complex than liquids will cause issues in terms of volumes, because these type of vessels, they're probably the biggest you can see is 300 or 400 kilos. So if you need like a bigger size, you can't really expect to do X number of batches on this. And then the type of mixing as well. So it's like a in bigger scale, something basically that happens in the lab. Then you can kind of upscale. These kind of vessels can go up to 500 kilos, probably a ton in some cases. There's a bit more sophistication. There is a proper command. It's more safety features as well. And this side vessel is also the auxiliary vessel that you need, say if you have more than one phase, especially if you have a phase in case of emulsions, for instance, phases that need to be heated. It's much easier to achieve these type of products in closed vessels with control and like a higher control of temperatures and mixing speed. I was referring to the phases. If you have, but you need to know the number of phases of your production, because if this is the setup that you have in your factory, the operator needs to be working in safe conditions. And if you have 15 different phases, he can't be surrounded by so many different kind of barrels and containers with a lot of like letters usually are used for phases from A to X. It's cause a higher potential of making mistakes, and making mistakes in this case are harder to track and could have like a bigger consequence than just scraping a lab batch. Then by kind of increasing the complexity of the type of products, probably this setup on the right hand side is something pharma, quasi-pharma. You can see there's a lot of sophistication. I wouldn't be surprised even if the commands or the type of software that runs the machine is much harder and much more complex than the previous two cases. You have many elements that you can control, but at the same time, many elements that restrict you in how you want the ingredients in the vessel to be mixed or to be combined together. When it comes to mixing, there is I think this is one of the biggest, if not the biggest, difference between lab and manufacture. Lab mixing gives you all these options. So you have propellers, 4 blades, 3 blades, 3 blades with Teflon, 2 blades. Then you have your dissolvers. You can have 3 blades that gives like a different kind of flow of the liquids inside your beaker. You can have a paddle stirrer that get yet another different flow, and you have your best friend that when you upscale is your worst enemy, which is a spatula, because you can stick it anywhere, you can give it a quick mix, but it's very hard to then quantify how that mix can be reproducible in the bigger scale. When it comes to industrial mixing, that's what you have. And you can't interchange the blades, the scrapers, with say like a 4 blades for the first say half an hour of mixing, then I move to the dissolver, and then I go back to the 3 blades. No, that's it. It's what you have. This, in fairness, is one of like a good quality mixing. I've seen all ranges, but here the ideal scenario is a closed vessel with jacketed walls, so it can be heated, or the usually is like heated with water. Cold water could be switched instead for the cooling, and ideally cooling should be controlled as well. Then you have scrapers, so you don't have buildup on the walls. So it's they're good to exchange the heat. So the scrapers bring the product towards the middle of the vessel, and at the same time they ensure that there is always bulk in it. It's always moving. If the jacket, if the walls are heated, there's no product overcooking or freezing if in case of the cooling down. Then you have the central blades pushing the products down towards the turbine that pushes it to the side. So this is a very ideal scenario. You also have input from to get materials from the bottom. So this being a closed system, potentially you could apply the vacuum for these in the system. Creating the vacuum helps to avoid incorporation of air in the bulk, and the aerated bulk, apart from not looking nice, which is not really the quality that you'd expect from a product you buy from a shop, but also causes issues in filling, because you want to make sure that the air is kept to a minimum. Because if you need to fill a 100 ml tube, you need to make sure that the quantity of the product that fits in the tube is correct, because all your calculation from quantity of bulk, then it goes all over the place. Here on the right hand side, there is like an output pipe, and in some cases, that's where you could have your recirculation going all the way to the top. So the bulk there's an extra way of ensuring that the bulk is properly uniform and mixed, just by dropping whatever comes at the bottom all the way up to the top. So it goes through properly. What I was mentioning before about the efficiency filling of the vessel, here it is dotted lines. They roughly show those levels. So this minimum amount to cover the turbine is the very minimum, but it only gets mixed by the turbine. So if you have anything below this, is not good for the turbine. Anything between these two dotted lines, it still doesn't get the proper mixing that it should have. Anything between these dotted line and this, so the vast majority of the space of the vessel gets a good mixing, proper mixing. Anything above the top dotted line may cause issues if you have to apply vacuum, or if you require kind of energetic mixing, you could have splashes, and you end up losing some products on the top, or on the side of properly not being properly mixed. So the vessel size is important to know beforehand. Optimizing manufacturing process. So the ideal scenario is that one operator is happy if he knows that he has to make one batch in one vessel in his one shift for work. So the one shift needs to take into account the quality control on the empty vessel, and they usually micro checks, or just checking that whatever was made before, there's no residues, especially if you operate in an industry with colors or dyes. You don't want to make something like a mascara and then afterwards a white skincare product, because it's going to be very hard to ensure that the skincare product is going to be white. So all these checks need to happen, then obviously manufacture and the release of the batch within the same shift. Depending on the factory, there is like big factories, they have their own team for cleaning the vessel. So the cleaning of the vessel can happen in a different shift for a different team, but the batch needs to be released within that shift. The pre-phases should be easy to handle and add to the vessel. So I was mentioning pre-phases before. Your pre-phase should be something that a normal kind of operator can lift on its own in safe conditions. If you're making a pre-phase of 200 kilos, obviously the operator cannot do it on its own. He can do it, he needs to get the tools to make it happen. It will take more time, so that kind of jeopardizes the one shift condition. The ingredients must be added to the vessel in the proper order, and this is mainly concerned to if you have heat sensitive ingredients, you need to know that after they're added to the vessel, you're restricted with the temperature you can have. If you have shear sensitive ingredients, you know that after they're added to the vessel, these ingredients cannot be cannot undergo very kind of high energy mixing. So the formulator and the operator, in their communication on how to make the batch, need to be aware of this and find the best compromise in order to optimize the manufacturing process. And last but not least, clear instruction for the operator, capturing the timing, the mixing, so what type of mixing, the speed of mixing, and what temperature, and what happens between the one phase and the next. The more detail the operator has, the clearer it is, the more efficient he is in making things. If you're saying that you need to mix for 10 minutes and then below 40 degrees add another phase, he needs to know how to get to 40 degrees, in how long he needs to get to 40 degrees, and what happens to the vessel. Is there any sort of agitation going on while the bulk goes from whichever temperature to the 40 degrees? So these information needs to be shared and agreed before even the operator starts to upload any ingredient or any phase to the vessel. Sorry. So bearing in mind that making cosmetic is not as easy as it may sound, there is bulks that are even more complex than normal to manufacture. And these bulks are the spa scrubs. All the scrubs are kind of tricky because you need to make sure that the exfoliating agent is evenly distributed throughout the batch. But in these cases, I'm speaking about anhydrous products. So products that don't contain any water, they're held together by the semi-solid crystalline structure that creates when waxes congeal and restructure. And the tricky bit is once it's in this form, you know that the scrub is going to stay there, but the filling is tricky. So and while you make it at high temperature to make sure that your waxes are melt, but at the same time they don't have the structure, so all your exfoliating agent drops to the bottom of the vessel. So you have to find a good mixing and a good way of bringing it down to the temperature where you're sure that the sample from the top of the vessel, from the bottom of the vessel, are similar and comparable. The second tricky bulk to make is these kind of, I've seen hair gels looking like this. And at the beginning, I thought it was a poor manufacturing method. In reality, it's a very complex manufacturing method because there is a degree of control of how much air goes in the bulk. It's tricky formulation wise, but it's also tricky to reproduce these kind of effect from the lab scale to manufacturing, especially consistent manufacturing throughout the whole batch. Toothpaste and clay masks, they have the same complexity because of the amount of powder that goes in the bulk. Having a lot of powder means that you don't really have a lot of water or liquid. So we're going back to that ratio of size of the bulk and your vessel, and also operating, so dispersing the powder into liquid, it requires a good proper mixing and good energy mixing. So because the product obviously needs to look smooth and nice. If you squeeze your toothpaste, you don't see lumps or kind of agglomerates of powders as you brush your teeth. Foundations are also tricky formulations to make because of the amount of powder here as well, but also the shade. So color matching is always tricky when it happens in a manufacturing environment. And the color and the cleaning process of the vessel. In my experience, I've worked in in Oriflame for cosmetic, for color cosmetics. There was a specific dedicated vessel for foundations and for mascaras. So the cleaning procedure obviously needed to happen, but it didn't need to be like the vessel didn't need to be spotless after cleaning. It needs to be sanitized and it needs to be pure from any sort of micro contamination. But you know that the following batch, it was going to be another mascara or another foundation. For foundations, the technology of making the foundation as we know them for the majority in the market is also tricky. I'm not going too much in detail for this in this presentation, but not everybody who can make skincare products can also make foundations. And sun care is also a high complex type of product to manufacture. Not so much for the selection of ingredient. The selection of ingredient is complex for a formulator. But the complexity when it comes to manufacture is due to the fact that there is a strict link to the safety of the consumer. If your product says that it's an SPF 20 and consumers start to apply it and you start to get complaints and you start to get adverse reactions, the product that is on the shelf is what the authorities will take, and that's the product that's coming out of the manufacturing vessel. So you need to make sure that the mixing of the ingredient is spot on, and you need to make sure that the product says what it does what it says on the tin. So that's the complexity is correlated with some products. Then I spoke about quality checks and the filling and packing. So quality checks for bulk is related very much to the standard that is made in the lab and very likely approved by the final customer. So the formulation need to send a reference to the quality control as a standard. Critical parameters need to be agreed. And again, as I mentioned before, for raw materials, critical parameters are, for instance, the pH for many products, but not for anhydrous products. It doesn't make sense to speak about pH for a lipstick, for instance. At the same time, viscosity is not something needed if you're making a liquid, because it's going to be water thin. It doesn't make sense to measure how thick something is. Density or specific gravity is something that is needed because of the implication in the filling process. Then specifications are required, especially for first productions. But for first production, they're really estimate, because your specifications, they're only a guidance for the quality control team to understand, is this product going to be fit for purpose within the packaging that it's going to be filled in. There is always going to be discrepancies between especially viscosity from a lab scale to a manufacturing scale. That's due to the type of mixing that you can achieve on a kind of desktop batch as opposed to a manufacturing batch. And it's also influenced by the vacuum. If you're operating in a desktop, it is very likely that some air is going to be incorporated in your bulk. If you're operating in proper manufacturing conditions with the vessel that I showed before, vacuum air shouldn't be incorporated, and that has an impact on the viscosity. But that's nothing to kind of be worried about. Once you have validated your process, then it's like setting up your standard for future batches. So you need to have the range, because you need to be able to highlight if something has gone wrong and something is not fit for purpose. But the range, you shouldn't be taking the range as the gospel, really, especially for first production and ranges coming from the lab. Everything needs to be adjusted, really. And then when it comes to releasing the batch and pumping out of the vessel, once the bulk goes from the vessel to your storage container, it could be like a barrel, it could be an IBC or whatever you want to keep it, microcheck needs to happen just to make sure that there's no contamination working within the batch. So you've made your batch. Before sending the bulk to filling, sorry, filling trials are required. And the filling trials is just to understand what's the most efficient way of setting up the machine and maximize the output from the filling process. So filling trials are needed to set up the filling speed, and that goes with it's the type of product and the type of bottle. So if you have like it's something very foamy, filling with if filling happens too quickly, then the foam starts to happen in the bottle, and obviously you're losing time and you need to kind of slow down. Filling volumes, it goes back to the incoming componentry check, making sure that the nominal volume is correct. And also filling trials happen either by volume or by weight. So you need to understand how much product goes in, and that's like a setup of each machine depending on each bulk that goes through. Labeling speed, so how quickly the label can be applied to the bottle. That depends on the shape of the bottle, but also depends on how big the label is, how accurate you want to be in terms of, or you can be in terms of displacement, vertical displacement of the labels. And then anti-tamper measures. What is it going to be? Sometimes it's a shrink wrap. Sometimes it's an extra sticker that goes on the finished product, and that needs to be factored in, because it could be an extra step that the bottle needs to go through from the filling machine. The finished product has its own checks as well. There is a micro specification, because even if your bulk is not contaminated and it's pure, contamination could be could come from the packaging. So you just want to make sure that there's the finished product that goes on the shelves is safe for use and it's pure. Obviously, you can't test every single bottle, so there is inline spot checks following the ISO 2849, and depending on your batch size and depending on your acceptability quality level, then this table tells you how many samples that you test need to be accepted, or up to which point you can accept the sample or you can reject the sample. So in this case, highlighted in yellow, for a 2.5 acceptable quality level in a batch size between 3,201 unit to 10,000 units, you can live with up to 11 rejections in your checks. But once you have 10 passes, it should be fine. So that's how you read the table. So once the packaging is happening, you need to know what happens to the end of it. So we're talking about pallet configuration. Your tube, let's say, goes through the filling line. What happens to the tube? More often than not, tubes come in unicartons. So the tube needs to be put into the unicarton. The unicarton needs to go in an outer, and the outer needs to go in a shipper, and the shipper goes in the pallet. So all these steps, apart from adding kind of work for the operator, they needed to understand and clarify how your distribution model is. Sometimes the outers are display outers. So it's the kind of boxes you can see, for instance, in Tesco or Lidl for detergents or cosmetics. So basically, you take the box, there is you can remove part of it, and then you have the units inside. And it's a kind of, you can take the boxes directly on the shelf. You don't have to transfer the content from the box to the shelf. But sometimes this happens for like a big distribution. But if you're talking to or about like a smaller distribution or smaller retails, then the single units is taken and put on the shelf. Another model works mainly for e-commerce, which is a pick and pack. And it works either in your kind of factory setup, but also at a the distribution center, like 3PL centers. They receive the pallet, but the units inside the pallet are then taken by an internal team. They need to kind of open the boxes, fill in the order based on what was ordered online, then create a specific box with the order for the specific customer, and then it's shipped. So if this is your business model, that extra step needs to happen. You need to be aware of this. Nothing kind of extraordinary or rocket science, but it just putting every element in its own into consideration if you're thinking about your business. And just like we had kind of cases of high complexity bulk to make, there's also high complexity bulks to fill and pack. So as I mentioned already, foaming products, I mean, are they complex? Maybe complex is not the right word, but you have to be careful how you fill it, because if you have splashes, or if you have if the foam develops while it's filled, it slows down the line massively. And if the foam overfills and then goes over, then you need to introduce someone who cleans the bottle. And if the product has dyes, like the example of the products we make, which are like tannin mousses, then you have someone very quick, because otherwise dyes stay in the bottle and it's all units that are lost. Premium skincare is also complex because it needs the one that look the best in retails, but you have to think and you have to look at this as every single component needs to be handled at some point in the filling process. So in this case, the bulk goes in the bottle, the label goes around the bottle, the cap goes on top of the bottle, then the bottle goes in the box, and the box, then the top of the box goes on the bottom of the box, which goes in another box and goes in a box in a pallet. So all these steps, they need to be addressed somehow in the packing process. And that's what I mentioned before at the very beginning about how the packaging comes in. These carton boxes, more often than not, come pre-assembled, which means that the operator, once they have a bottle with the label and the cap, needs to take one of these boxes, take it apart, put the bottle in, put the box back together. And if you do this beforehand, because every top is associated to its own bottom, a mix and match of all the tops and all the bottom creates only more confusion. So it goes without saying that yes, premium skincare is sold as a premium, but there's all these indirect costs that they need to be taken into account. There's lots of margin, don't get me wrong, but it's like more than ordinary costs that are that come in play, especially if you think of boxes then eventually need to be closed with a nice ribbon. Somebody has to do it, so somebody needs to be instructed to do so. The other kind of elements that drive complexity is clear labels. Clear labels are the nicest, but they're also the hardest to apply on the material, especially on glass, because glass is not as smooth as a plastic bottle, and every little imperfection causes something that is kind of increased tenfold when it comes to being noticeable as like a defect. So clear labels. Don't be surprised if someone asks for a little premium if you decide to go with clear labels. Products that sediment, the famous shake well before use. They're complex because of the consistency that you need to guarantee between the beginning of the filling process and the end of the filling process, and making sure that kind of those labels, those tables for the ISO and the military standard for online checks, every single unit needs to be equivalent to each other. Maybe not necessarily identical, but equivalent. And that requires a specific kind of creativity from the engineering team of the factory. Similar case with the dual phase products. Dual phase products are products that tend to sit in two different phases. So you can fill in two ways, either as two steps, which as the word says, it's two steps of filling, so more cost, or as a unique product, always being mixed, and that it separates once it's in the bottle. But again, you have to make sure that the first bottle is equivalent, comparable to the last bottle that you fill. And guaranteeing that consistency requires effort, and as I said, for the previous case, creativity from the engineering team. So we've covered all the steps from incoming raw materials, transfer from what the factory needs to know from a lab or from formulation, to making sure that the product that goes on the shelf or goes in the hand of the end user is what the brand owner, the brand company had in mind, going through the specifics of how to make it, how to fill it, how to pack it, and your product is ready to leave the factory and be very successful on the market. So thanks for your attention. And as Naya said before, the floor is open for any question.
Great. Thanks very much, Paolo. That was very interesting and informative. So the floor is open to questions now. So as I mentioned at the beginning, if you'd like to use the raise hand function, or either that, or you can put your question into the chat box. So yeah, if anyone has questions.
Do you want me to stop sharing, or?
I think you could probably maybe leave the slides up for now, just in case
Okay.
there's any particular slide you need to reference, depending on the questions, Paolo. So I just might start there, just kick off the questions there. So just two quick questions. So you mentioned in relation to mixing that there's some challenges associated with going from a lab scale to industrial scale.
Yeah.
And you had the different instruments there as well that you can utilize. Is there any key considerations when addressing that transition from lab scale to industrial scale? Key tips that you think would be important for people to know setting up or starting out in that scaling up?
Yes. So as much as possible, the way I learned how to formulate at the bench is following the like design for manufacture guideline, which means knowing what you're going to have in the big scale, you should try to mimic as much as possible in the smaller scale. Because nobody is interested in being successful at the lab if then the product is not reproducible. And by the time everybody's so excited about having something good from the lab, then you don't want to give the bad news of, okay, so now we have to make a massive investment to buy a vessel to reproduce what I've used in the lab, because that's not going to happen.
Yeah, it's really good piece of advice, I think.
Yeah.
Because it's easier to work backwards from what you know the industrial setting might be, and to try and get that to match it in the lab scale rather than the other way around.
Yeah, which in the way could be a challenge, and depending, because I don't really know the audience, but if you're thinking of getting formulation done with say one formulator, but then scaled in another site of someone doesn't offer either the manufacturing capacity or the formulating capabilities, then you have to factor in the fact that the formulator has been formulating blind, not knowing who will make it in the end, and the manufacturer needs to reproduce something that he does know how it was made in the first place. So that adds an extra bit of complexity from ideation to launch.
Excellent. Just one more question from me for now. In relation to contamination, like, are there any key tips in terms of avoiding it? I know, trying to be as aseptic as possible is always the main approach, but in general, what are the kind of main approaches that you need to put in place to reduce the risk of contamination? And then to follow on that, when you do find a contamination, what's the best way to tackle it and to deal with
it? In terms of avoiding contamination, it's you have to think of your manufacturing environment as a kitchen. So the level of cleanliness needs to be spot on. The practices of the operators need to be, there's no going cheap with when it comes to safety, because contamination are tricky ones, because it can happen later on while the product is in the market. And you have to put yourself in the best situation of being confident of your results. Sanitization procedures need to be validated and probably reviewed. A proper understanding of the water quality that you're dealing with, and a system to guarantee the purity of the water that's used is always good. If you do find a contamination in your product, you have to understand where it comes from. It could come from a high load of microorganism coming from one of the raw materials. So that could be one route for investigation. It could come from maybe failure of your water purification system. Or it could come from maybe just simply the operator forgetting to put a preservative in the product, and or maybe storing the for kind of a manufacturing benefit in inverted commas. You thought that it was quicker to load your water in the vessel the night before, and then you leave the water sitting still in your vessel over the weekend. Maybe it's a bank holiday, maybe it's a summer, and you just carry on with the operation as nothing happened. That could be the biggest kind of culprit for then finding your contamination at the other end of the product.
Obviously, it depends on the vessel type, but do some of them come with the sterilization cycle that you can use? You know, you're able to heat to certain temperatures. Can you run a cycle where you set it very high to kill off some microbes?
Yeah, you can. Yeah, that's a way of doing that. Just bear in mind that if you're dealing, it depends on the size of the vessel. If you're dealing with like very big vessel, it's a lot of water by the time you fill your vessel. There's always kind of complex vessels. They always have nooks and crannies where water can stagnate and sit there. And obviously, once more water gets added in, it kind of flushes it, and it's back in the system. So sanitization procedures needs to be kind of in place and validated and controlled on a regular basis.
So the QC would be very tight for that as well as the performance of the actual formulation.
Yeah.
Is there any, and sorry, no, I know I just one more thing to ask you from me is, do you know of any kind of online resources for information in terms of the different types of formulation when you're scaling at industrial scale, like in terms of the considerations for different types of products? So like you mentioned earlier, just as an example, you were saying a skincare product and a mascara going from one to the other, in terms of their handling, their composition, of what might need to be considered if going from one to the other in terms of chemical treatment to clear out the coloring or the dye or anything like that. Any kind of resources that people can use as a reference for the manufacturing process, I suppose, the technical aspects of it.
Well,
troubleshooting even,
yeah, well, most of it could be most of it is common sense. Like obviously, if you have a mascara, you know that a good scrubbing it works better than any online research. If you have like organic dyes, there could be some specific chemicals that you can use that breaks down the dyes. So it's not just a washing off, a further constant dilutions, but making sure that the dye is just not like it's not present anymore. Obviously, it also depends on the type of the business and the volume of the business. What I mean by this is, if I have one color product in my portfolio and I'm making 100 white products, I probably won't bring in a specific cleaning agent for that one product. I'd rather organize my scheduling so that if I can maybe make the color product for the next 3 months in one go, I will do it, and I will clean the vessel properly only once every 3 months or 6 months. There's ways of going around it and being efficient without necessarily thinking of starting from scratch and the ideal perfect scenario, because I mean, bear in mind that some vessels, by the time you take them apart and you put it back together, it's all downtime for the factory. So the factory always want to be more efficient, doing many of the things that work well in the easiest way possible. So it's just finding that compromise. And there's other ways, as I said, scheduling is one way. Sometimes you may decide that your color is added during the filling. So your manufacturing vessel, which is the most complex to go through a proper cleaning because of all the pipes and connections, is kind of there and spotless and ready for use. And your filling process, your filling equipment, which is in a way easier to clean, is the one that takes the hit from a cleaning perspective. So there's different ways of going about being creative, and still getting the end result.
Yeah, being economical, I suppose, with the whole process, taking the larger workings into consideration. So that's very useful. Thanks. So we have a question in the chat here from Arnold, and it says, "Thanks, Paolo, for the informative presentation. What are some of the considerations regarding the shelf life of the product?"
Well, shelf life of cosmetics come from the testing, and the safety assessor. He's the one going through the stability testing, says, okay, I believe this is stable for at least 30 months. That's what cosmetics are stable for. Obviously, it's internally, every manufacturer has its own procedures, and it's related to how the bulk is stocked. And also it comes in a way, it's related to the size of your warehouse, because you can't always make a lot of bulk and store the bulk. For this reason, you tend to do just enough to fulfill the order. And you may just want, even though the testing shows that the product is stable for 30 months. Obviously, it comes from an accelerated stability, just bear in mind. So it's always good to have regular checks of the bulk every 3 or 6 months, just to make sure that the prediction of the accelerated stability during development is actually accurate. But also you need to know how the product evolves over time, because it's not right to compare your specifications to the time zero specifications. Usually pH can drift upwards or downwards. The fact that after 3 months your pH unit has gone down by, say, your pH has gone down by 1 unit, it may have brought the product out of the spec from time zero, but still the product may still be good to be filled and used by the end user. So you need to understand that you may need different criteria to evaluate if the product is still fit for purpose.
Very good. Okay, thank you. We've time for one last quick question if anyone has one. So I'll just give you a second there. Otherwise, you can contact Aoife Curran or myself directly, and we'll be able to direct those questions to Paolo afterwards. I guess in the interest of time, we better finish up, and I'd like to finish up by thanking Paolo again. We greatly appreciate you sharing your knowledge and expertise on manufacturing with us today. And thank you to the attendees. Cheers for registering and attending today.